Okay, so maybe you've heard someone say mod a flashlight. Well, technically you've probably read it on an internet forum because no one says that in real life. I mean, I've never heard anybody say it. And you want to know how? Well, all flashlights are slightly different in the way you mod them, but the two most common types of modifications are swapping out the driver or flashlight computer and the LED. I'm going to use a very easy light to mod on, the Brinyte B158. It uses a drop-in module or pill that is removable by hand and swappable, so you can throw in different types of LEDs quickly if that's what you're into. Anyway, so I have a module with a red emitter and driver, and I'm going to remove it from the light. Cool. I would like to put in a higher output, better throwing white light LED and a high current driver to, drive the LED, right? So I have to remove the LED and driver from the light. The LED makes the light. The driver controls the light output and modes. Okay, so I remove the pill. I desolder the leads from the leads from the LED. The red is a positive and the black is a negative. Duh. The emitter you see sits on top of the MCPCB. It is held in place there by a few drops of solder. The emitter and star I'm going to replace the red LED emitter star combo with is going to be a Cree XPL high or high intensity. It's actually Cree XPL HI. It doesn't have a clear dome on it like most Cree LEDs, so it makes the LED throw more better, or allows the light to travel longer distances in non-geek talk. Then I take a screwdriver on my Leatherman here and pry up on the MCPCB. This one is glued with some thermal adhesive by evil people, and it makes it harder to take off. A lot of MCPCBs, that's like a mouthful, have just thermal paste or grease underneath, so prying isn't necessary. That is, unless you want to look tough. Next, I want to pop out the driver. I stick a cute little, compact and manly screwdriver through and hammer it out. This may not be the best method because it will probably damage the driver, and I did, which is okay if you're not using it again or just like making trash for the earth. There was a bit of solder on the underside of it, attaching it to the pill, which is why I kind of screwed it up. Okay, so that's out. Let's put in a new driver and LED. But before we do that, here's a closer look at the old LED and driver. You'll see the LED is actually mounted on the MCPCB, so it kind of looks like one part, but it's actually two. Next, I'll Dremel out all the thermal glue because it's quick. Okay, let's put the new driver back in. This pill happens to take a common sized 17mm driver. I file the burrs on the edges down on the outside of the driver, put the positive and negative leads through the hole, and hammer it lightly in until it makes contact with the interior brass lip. The ring on the outside of the driver is a negative or ground, so it needs to make contact with the brass module to make the flashlight operate. Okay, so next I'll put the new LED star or LED MCPCB. I think star is probably easier to say. The diameter of the star, even though it's not star shaped exactly, on this light is 16mm, so larger stars won't fit. First I put on some thermal paste, not adhesive, because I want it to be easier to remove in the future. But before we do anything else, we need to put a little bit of extra solder on the star so the positive and negative leads have something to latch onto, so do that. Then you solder the plus and minus. It's going to be hard to screw up because there's actually a little plus and a little minus on either side, so red on plus, black on minus. And after that, we're done. Then we put on the plastic parts, the centering disc, the centering ring, and the spacer. Screw it on, put it back together, and then basically you have a complete pill that is ready to put back into the Brinyte B158 flashlight. But before we do that, we have one other thing. Flip over the pill, bridge some solder on the negative ring of the driver to the brass pill. Some people like to bridge some on the inside, but that's a bit more advanced. Although I guess I could have done it here, but whatever, I didn't. But it works fine on this light. Okay, cool. So put the pill back in the flashlight with the battery, turn it on. Okay, I've reviewed this light in the past, so let's now compare the output of the old module, which I still have the white light module, and the new one with some beam shots so you can see the difference in output. I have both pills, so I'll just swap them in and out of the same flashlight easily. Okay, and also I'm going to throw in a few other thrower lights for good measure. You can see the light now outthrows and has a higher output than the original LED module. The aspheric lens on this light allows it to shoot a high intensity pinpoint of light at a great distance with very little edge spills. These lights are useful for lighting up very specific areas far away and can be adjusted, like the spill and the focus of the light. So you can use it for a nice even output or something very far away. The driver was about $12 and the LED was about $6 from website Mountain Electronics. Alright, so this has kind of been boring as shit, but if you like this sort of video and outdoor gear review in general, please subscribe and browse my channel if you're still awake. But maybe you've learned something, so that's good, right? Like maybe not Google flashlight repair tutorials. Hey, thanks for watching.